the review for Module 7. So my slope on this one is -5. That means I'm going to go downhill. And my y-intercept is 2. So here's my y-intercept of 2 here. Down 5, let's see. 1, 2, 3, 4, 5 over 2, 3, 4, 5 over 1. There we go. Okay, so we do have that. Then it says less than. So if I did 0, 0 on this, would it pass? It would be 0 is less than 0 plus 2. Okay, so that would work. So that shading works. No. So we know this one is correct. So let's look on ABC. Ooh, that might be the answer. So let's look at this. Okay, my slope on this one is going to be -1. So that's, again, going to go downhill. It's going to go through 0, -2. So 0, -2. It does go negative direction, and it says greater than. So if I was to plug in 0, 0, I would get 0 is greater than or equal to 0 minus 2. 0 is greater than or equal to -2. So it is above. So A is your answer. Let's come over to this one. Now I have to solve, get it in the y equals mx plus b form. So if I subtract x from both sides, then divide by -1, that'll change the direction of the inequality and get x plus 1. So my slope on this is 1, my y-intercept on this is 1. It is an open dot or dashed line. Okay, so if I go here, y-intercept of 1 right there, and a slope of 1, that is correct. If I look at the point 0, 0 on this, I would have 0 minus 0 is less than -1. Is 0 less than -1? No, it is not. So it wouldn't go this way, it would go this way. And that is not going to be that one. So we have to have the same kind of line, but it goes above the line. So this one could be it. That one cannot because it's going through the point 0, 3, and we wanted to go through the point 0, 1. So this one is the answer. Okay. This one, write an inequality. So anytime that you have a vertical line, it's going to be x. And what value is x there? It is 0. Are those numbers getting bigger or smaller? They are getting smaller. Is it a dotted line or a solid line? It is a dotted line, so it does not get an or equal to. Okay, if it's a horizontal line, it's y. The number that it is at is 4. It is a solid line, so we are going to have the or equal to, and it's all the numbers are bigger than it, so it's going to be greater than or equal to. What is the solution of a system of linear equations that has the same slope? So the slopes are the same, and the y-intercepts are the same. Okay? That means it's going to be infinite solutions. Because it's the exact same equation. If they have the same slope and different y-intercept, that means that you're going to have parallel lines like so. So that would be no solution. Okay, if I'm going to do this inequality, -1, that's an open dot, up 2 over 1, up 2 over 1, up 2 over 1, down 2 over 1, down 2 over 1. That is a dotted line. If I was to put in 0, 0 as a test point, I would get 0 is greater than or equal to 0 minus 1. Is 0 greater than or equal to -1? It is. So all of this up here would be shaded. Again, we just talked about anytime it's X and a number, there's no Y involved, you're going to have a vertical line. So we're going to have a solid vertical line here at 5. And it says numbers greater than. So it's going to be the numbers that are up here. This one, write an inequality. Well, my y-intercept is 4. Then my slope, let's see, it's going to come down, and that's probably at 1. So we're going to go down 2, 4, 5. So this right here is 5. We're going to go over 2, 4. So that's going to be negative 5/4 x. Now, is it shaded above that line or below? It's shaded above. So it's going to be y is greater than negative 5/4 x plus 4. Over here, these are going up by 2, so this would be at 1. So at negative 1. The slope on this, I go down 1, I go over 2. So negative 1/2. It is below that line, so it's less than. Okay, on this one, I go to negative 1. Let's see, this right here, sorry, this is the axis right here. So if I go to negative 1, and oops, I can hardly tell that that's an open dot. And I go down 3. 1, 2, 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. Like so. I'm going to take my phone off the hook so I don't get a phone call. And I'm going to go, it says less than, so it's below that. Now, I could have taken a point like 0, 0. 0 is less than 0, negative 1. Is 0 less than negative 1? It's not. So this right here would not have been a point. Then I come over here to this one and I go up to 3, and it's a solid dot. And my slope is 1, up 1 over 1, up 1 over 1. Like so. That is greater than, so we're talking up here. So the solution for this would be all the points in this area right here. Okay, let's come over to this one. I have a solid line on the top one, so that's 2. So I'm going to come here to 2. Go down 4. 1, 2, 3, 4 over 3. Oh, that's 2. Over 3. Up 1, 2, 3, 4. 1, 2, 3. Is that right? Yeah. So this is going to be, okay. And it's greater than, or you can put in the point 0, 0. See if it works. So 0 is greater than or equal to 0 plus 2. It is not greater than 2. So it would be above that line. Then I come back to this. And I go to negative 3, and that's an open dot. I go up 1, over 1, 2, 3, or down 1 and over 3. Notice how I go all the way through the coordinate plane. I'm going to look for, okay, if I was to put in 0, 0, that would get me 0 is greater than 0 minus 3. 0 is greater than negative 3, so it is up here. So The overlapping portion, this part right here, is the actual solution. Okay, I go to +2, and I make a solid point, up 1/3, down 1/3, and I try and get as best as I can. Okay, if I was to plug in 0, I'd get 0 is less than or equal to 0 plus 2, and that is true, so that would be down here. Then I can go to -3, and that is a closed dot. I go up 1/3, down 1/3. That is greater than, if you want to plug in 0, 0, 0 is greater than or equal to 0 minus 3. That is true. So that is this up here. And the solution set is all the stuff in between the two lines. Okay, on this one, solve for y, I get -y is greater than -x plus 3. Divide by a negative, I have to switch my inequality, x minus 3. So I go to -3, open dot, a slope of 1. Like so. Oh, if I was to put 0 in, I would have 0. Oops, I meant red. I would have 0 minus 0 is greater than 3. Is 0 greater than 3? It sure is. So it's all this stuff up here. Then on this one, I would do y is less than -2x plus 3. So I'll go up to +3 and make an open dot. And I go down 2 to the right 1, down 2 to the right 1, down 2 to the right 1, down 2 to the right 1. Okay, if I was to plug in 0, 0, I would get 0 plus 0 is less than 3. Is 0 less than 3? It is. So it's going to be this portion over here. And the part that is the solution is this right here. Okay. Solve this system by graphing. Oops, there we go. I go to 3, and I plot a point. I go up 2, 1, 2, and I go over 9. Or down 2, 1, 2, and over 9. There we go. Then I do the other one. I go down to -6. I plot a point. It's going to be -7/9. So I'm going to go up 7. So 1, 2, 3, 4, 5, 6, 7. And I'm going to go over 9. Well, that worked out very nicely. So the solution to this is -9, 1. This one, I go down to -8. I go up 1 over 2, up 1 over 2, over 2, up 1 over 2. I don't know why these lines are different colors. I don't know. Very weird, but that's okay. I'm going to do green. So I'm going to go to -3, plot a point. I'm going to go up 3, 1, 2, 3 over 1, 1, 2, 3 over 1, 2, 3 over 1. Or down 3, 1, 2, 3 over 1, 1, 2, 3 over 1. Oh, look at that. They ran into each other. except it didn't like my drawing. There we go. So that is at the point, let's see, -2, -9. Over here, I have to solve for y first, so -y equals -2x plus 2. Divide by a negative, and I get 2x minus 2. So I go down here to -2, and I have a slope of 2, so up 2 over 1, 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 or you could have gone down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. And then draw a line. That wasn't a very pretty one, but that's okay. This one, solve for y. So I'm going to get -3y equals -2x plus 18. Divide through by a -3, so I get 2/3 x minus 6. So I come here. I have a slope of 2/3, so up 2 to the right 3, 2 to the right 1, 2, 3, 1, 2, 1, 2, 3, or down 2, 1, 2, 3. Look at that, they ran into each other. Okay, what's the point that they ran into each other? That looks like -3, -8. Okay. So on this one, I'm going to subtract 4x to the other side and get -7y equals -4y minus 21. Divide through by 7, or -7, and get 4/7. Oh, I don't know why I put a y. There we go. How about an x? X plus 3. So I go to 3 and plot a point. I go up 4, so 1, 2, 3, 4, and over to 7. Or down 1, 2, 3, 4, and over to -7. Okay. And then on this one, I'm going to subtract 16x, so I get -7y equals -16x plus 63. Divide through by a -7, so I get 16 over 7x minus 9. So I'm going to come down here. I'm going to go up 16. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And I'm going to go to the right 7. So over here to 7. So they run into each other at 7, 7. Okay. Sorry, I can't get it to there. John is messing with his little sister. He tells her that he is holding $1.95 behind his back, and he is holding exactly 9 coins. He says, "I'll give you the money if you tell me how many dimes and quarters I have." Help his little sister get the money. How many of each type? So we're looking for dimes and quarters. So I'm going to let D equal number of dimes and Q equal number of quarters. Okay, so if we're talking about the number of them, he has exactly 9 coins. So D plus Q is equal to 9. Because Then the other one is going to be the money amount. He has $1.95. Well, how much is a dime worth? It's worth 10 cents. How much is a quarter worth? 25 cents. And then it's $1.95. Now let me make sure that yes, $1.95. Now you guys hate decimals. So if you were to multiply everything through by 100, you would get 10D plus 25Q equals 195. Now, you can either do substitution. Does it ask? Nope, it doesn't ask which one. Or you can multiply through. I personally like to do elimination, so I'm actually going to multiply through by negative 10. So negative 10D minus 10Q equals negative 90. Add these together, and I get 15Q equals 105. Divide by 15. I actually don't know what that comes out to. I should. Isn't it 7? Yeah, this comes out to 7 quarters. And if I plug that back in to the first equation, I have dimes plus 7 equals 9. So D equals 7. So, oh, nope, try that again. How about 2? Because we subtract 7. So there are 2 dimes and there are 7 quarters. Okay, elimination. Well, none of these are going to cancel out. So this already has a negative on it, so I'm going to use x's. Does it matter? No. So 2 times 5 is 10, so that's what our common number is going to be, so our common multiple. So I'm going to multiply this by 5 and get negative 10x plus 20y equals 90. And I'm going to multiply this one through by 2. I'm going to get 10x plus 10y equals negative 60. I'm going to add straight down. I'm going to get 30y equals 30, so y equals 1. I plug it back into either one of the equations. I don't care which one. I'm just going to do the top one. Negative 2x plus 4 times 1 equals 18. So I have plus 4 equals 18. Subtract the 4. Get negative 2x equals 14. Divide by 2, or negative 2, and I get negative 7. So my answer would be negative 7, 1. This one. On this one, we don't even have the x's and the y's on the same side of the equal sign. So we have to do that first. So this needs to go to the other side. This needs to go to the other side. So I'm going to add 4y to the other side, so plus 4y. I'm going to add 5 to the other side. And then I'm going to bring down x plus 2y equals 4. Now, right now we don't have anything opposite of each other, so I'm going to multiply this by negative 2. So I'm going to get negative 2x minus 4y equals negative 8. I'm going to bring down that first equation of 2x plus 4y equals 5. Now, hopefully you've already seen what's going to happen here. If I add straight down, that's going to get me a 0, that's going to get me a 0, and this is negative 3. These never equal each other, so your answer is no solution. Okay, on this one, I'm going to do substitution because it's already set up for substitution. Oh, no. It says either or. So I'm going to plug this in for y right here. So I'm going to get negative 3x plus 6 times the quantity, 5x minus 2 equals negative 12. So I get negative 3x plus 30x minus 12 equals negative 12. So I get 27x minus 12 equals negative 12. Add 12 to both sides. When I do that, I'm going to get 27x equals 0. Divide by 27. get x equals 0. I'll plug that back into the first one because it's the easiest one to do. And I get y equals -2. So the point is 0, -2. Okay. Over here, again, you can do substitution or you could do elimination. This is already solved, or is not already solved, but it has a coefficient of 1. So I'm just going to move that 2x to the other side to get -2x plus 20. And I'm going to plug it in here. So I get 6x equals 5 times the quantity, -2x plus 20. And then don't forget the plus 12. So I have 6x equals -10x plus 100 plus 12. Add 10x to the other side. I get 16x equals 112. Divide by 16. And I, of course, don't know that off the top of my head. Let's see. Seven. And so I'm going to take that and I'm going to plug it back into 2x plus y equals 20. So 2 times the quantity 7 plus y equals 20. 14 plus y equals 20. So y equals 6. So it's the 0.76. Okay, Samantha is doing chores at home. She can vacuum a room for $2 or wash and fold laundry for $3. 1 month, she accomplished a total of 25 chores and a total of $64. Write a system of equations to model the situation, then determine how many types of chores she did. So what are the 2 types of chores? So we're going to let, I don't know, V equal vacuum. And laundry, no, I don't want to do I'll do W equals wash. So how many total chores did she do? She did 25 chores right here. So V plus W is going to equal 25. Then how much money did she get? $64. So she can vacuum a room for $2. So 2V plus, she can get $3 for washing and folding. And she's got a total of $64. Okay, I don't care how you solve it. I'm going to multiply through by -2. -2V minus 2W equals -50. Add those up. I would get W equals 14. So I plug it back in. So V plus 14 equals 25. So V is going to equal 11. So that's not what I was trying to do. She vacuumed 11 times and washed and folded 14 times. And why I made it so tiny, I don't know. So we're going to look over at this next and see, is 5, 4 a solution to the system? So we go over to 5, we go up to 4. Is that point right there a solution? Yes, it is. That is a solution. Yes. It is in the overlapping shaded region. Then we have 2, 3. So we're going to come over here to 2, and we're going to go up to 3. That line's on the line, and it's a dotted line, not a solid line. So no, it lands on a dotted line. And then 6, 5.7. So I come over to 6, I go up to 5.7. And that is in the shaded area. Yes, it is in the overlapping shaded area. Okay, if I told you that the solution to the system represented by the number of girls, X, and number of boys, Y, at a high school dance, what would you change your answer to for number 27? 6 girls and 5 boys. You cannot have 5.7 boys. Oh. Sorry. We would have to change it to no, because you can't have 5.7 boys. The pharmacist needs 100 gallons of 50% alcohol solution. She has 30% and 80% solutions available. So let X equal the number of 30%, Y equal the number of, the number of gallons of the 80%. So we need a total of 100 gallons. So X plus Y is 100 gallons. Then the acid in the solution. We have 30%. We have 80%. And we want 50%. Okay, so I don't want those decimals, so I'm going to do 30x plus 80y equals 50 times 100. Oops. So that's 30x plus 80y equals 5,000. Oh no, I'm going to just multiply this by negative 30. So negative 30x minus 30y equals negative 3,000. So I get 50y equals 2,000. Divide by 50. Y equals, that's going to be 40 gallons of 80% acid. And if I plug in the other one, I would have X plus 40 equals 100. So X equals 60 gallons of 30% acid. Okay. Hey, all the answers are down here.